Assalamu alaikum. Okay, so what is chapter 6 all about? It's about continuous variables. Remember continuous variables from chapter 1? What's a continuous variable? Give me an example of a continuous variable. Anyone remember? Speed, time, temperature, weight. All these are examples of continuous variables. Okay? So chapter 6 is about continuous variable. And chapter 6 also is extension to probability theory. So it's also about the probability. So we have a continuous variable and you ask about the probability. So the continuous variable that we have, we call it x, okay, has a distribution. Remember Chebyshev? We didn't know the distribution shape in Chebyshev. In this case, we know the distribution shape. It's a bell shape. Remember the shapes? It's a bell shape. And not any bell shape. We know exactly the equation of this curve. We know everything about it. So it's called the normal distribution curve. So that's a normal distribution curve. Okay? It's many of the variables are actually approximately similar, close to the normal distribution. And because we know the equation, we can get the probability very easy. And the probability in this case is the area under the curve. The area under the curve. This area is actually representing the probability. And from chapter 4, you know the sum of probability must be 1. And that's why the total area under the curve is actually 1. Now, this curve is symmetric. Symmetric means in the middle you have the average, the mu. Remember the variable could be speed, as you said, right? It could be weight, could be anything. It has an average. Suppose the average speed mu is 100 kilometers per hour, for example. And it also has standard deviation. Okay, suppose the standard deviation is 20 or whatever. So now I have this variable that's normally distributed. It has an average, it has standard deviation, it's a continuous variable, and I can get the probability if I know that it's approximately normally distributed. So the probability is the area under the curve. See, the area is 1. This shape is symmetric. Symmetric means that imagine you have a mirror here in the middle, so the right side will be approximately identical, or actually exactly identical to the left side, which means if you just fold this, then they will actually coincide. It will be the same thing. So that means the area here is 0.5 and the area here is 0.5 because the total area is 1. Right? The area on the right of the mean is half. The area of the left of the mean is also half. So if I tell you, for example, if you select one car randomly, what is the from this population? What is the probability that the speed of the car is more than 100? More than 100. 50%, 0.5. Right? Because the area, more than means this area. The probability is actually the area. So the probability that the car actually speed is higher than 50% than 100, which is actually the average, is 50%. The probability is lower than 100 is also another 50%. Right? So how about if I ask you, what is the probability that the speed of the car is more than 80? More than 80. So 80 here is a value, x1 is equal to 80, is a particular value. This 80 is less than 100, so it's going to be in the left side. So that means we need the area here. Above 80, the speed is here. That means the probability is going to be all these areas. So we need to get this area. So how am I going to do that? Again, from a formula, but we don't use the formula. We use a table. See, in chapter 5, we have formula and we have table in the binomial. We have binomial formula, NCX, P power X, Q power N minus X, and we also have the table. Here we only have a table. So we go to the table and find the area. That's the solution we'll be using. So the table will be given to you in the exam. But the problem is, how many tables we need to create? We need to create a table for every variable x. There are many variables which has different means and different standard deviations, and that's impossible. We cannot do that. So we have to agree on a standard. The standard is another variable. They called it z. The z it's called the standard score, and it has a mean mu equal to 0 and had a standard deviation sigma equal to 1. And for this, they have built the table. For this, you have built the table. So that means what? That means if you have any variable, x, which could be speed or temperature or anything, somehow you have to do mapping from x to z. Like if this is x1 is 80, what is the corresponding value z1 here? How does this happen? It's a very simple idea in mathematics. There's just a mapping between two axes. They are different in the mean and different in standard deviation. The difference in the mean is like shifting. Like you have an axis here and you shift it to the left or to the right. That's happening because of the difference of the mean. And the compression or the stretch of the axis is done by the sigma, by the standard deviation. Right? To move from sigma 20 to sigma 1, you're actually stretching or compressing the axis. Okay? So in mathematics, this is a very simple formula. We'll do that for you. Z equal to x minus mu over sigma. The minus mu is the shifting, and the dividing by sigma is the compression or the stretch based on the value of sigma. Okay? So that's mathematical mapping. See, the curve itself didn't change. I mean, the distribution for Z is the same as the distribution for X. Exactly same curve, exactly same shape. The only difference is the axis shift and compression. And that happened mathematically by this formula. So that means what? That means if you have the speed and you want to know the area to the right of x equal to 80, all you have to do is to map this x to z first, and then take this z to the table, and then you have already a table that will give you the area. Okay, so let's do that. Let's do it. The first step here to get that. So you have x1 equal to 80, and z1 is actually going to be 80 minus mu, which is 100, and then divided by 20. 20 is going to be what? Minus 1. Okay? Z is minus 1, so I have minus 1 here, right? Z1 is equal to minus 1. So that means I can now go to the table and get the area. So the area work with the table. The area work with Z. So that's it. So where is minus 1? See, the Z will be actually, it's going to be in that side. You know, the Z in general, this is the binomial table, the normal distribution. The Z is going to be here, and the area is going to be in this part. So Z is equal to minus 1. Where is it? It's almost here. That's it. Okay, so Z is minus 1, and the area very simply is just right in front of it. That's it. So the area is 0.1587. That's it. So the area I'm looking for is 0.1587. So that's it. The other values, we'll talk about it. 0.1587, so that means area 1 is 0.1587. And if you noticed, if you go back to the table to see how it's actually designed, is just giving you the area on the left side. See that shaded? This is the area given in the table. The table only understands the area on the left side of Z, which means from minus infinity to Z. So in this case, in our case, this will be here. This is 0.1587. But this is not the area I want, by the way. I want the area on the right side. So you know the complementary idea, the total area is 1. So the area you want is actually the answer you need. Will be 1 minus area 1, and then you have to subtract 1 from this. And that's the confusion that happened in chapter 6. The area, where is the area? Is it on the right or on the left? Where is the Z? Is it positive or negative? That's a whole game. That's why the more questions you see, you probably have a lot of videos. Some people saying, why you have so many videos? It must be a very big chapter. It's not a big chapter. We're only just playing with the direction, where is the right, where is the left. So if you know your right from your left, then you should be fine. Okay, so that's the idea of chapter 6 mainly. You have a variable, continuous variable, be speed, temperature, salary, anything. It has a mu and sigma, mean and standard deviation. It's normally distributed. We know the curve. And we want to get the probability that someone selected, one car selected, one person selected, the salary is higher than this, or above this, or between this and this. The probability that we want is actually going to be an area. How do you get this area? We have to use an intermediate step. This intermediate step is Z, because we cannot build a table for every variable X of all different kinds. So you have to have one table, standard table, for something called the standard score Z as an intermediate step. And to reach to this table, to get the area from this table, you really have to map from X to Z first through this formula, which is a simple formula in mathematics. By the way, this formula is very similar to the K of Chebyshev. Do you remember the K of Chebyshev? That's almost the same. The Z of the normal distribution, the Z score, is very similar to the K of Chebyshev. The only difference is that between Chebyshev and normal distribution, the normal distribution, we know the curve exactly, but in Chebyshev, we don't know. That's why our answers say at least. It doesn't don't know exact percentage or area. Okay? Once you do this intermediate step between the variable you have, the continuous variable you have, which is speed in here, to the Z, then you can actually go to the table and get the area. And then, of course, you have to ask yourself this important question. The area give you in the table is the area you want or something else? If it's something else, you have to tweak it a little bit. Maybe you add something, maybe you subtract something. You have to be careful. Yes?
the speed less than 80, then it will be safe.
Yeah, if in this example, until you find the probability that the speed is less than 80, you just use this area, and this will be your final answer.
So it's always like the one.
Yeah, less than 80 means the area on the left, which is already given by the table.
Z is like always.
No. The Z on the left side, because 80 itself, there's two things, by the way. The direction of the Z, or X, and the second part is the direction of the area. There's two things. You ask yourself, the X, is it on the right or left of the mean? Second question, is the area to the right or left of X? There's two questions here. So in our case, the X itself, because it's 80 smaller than the 100, is going to be on the left of the mean. It's going to be in that side. But the area itself is on the right. So there's two things, and that's what makes the questions vary. And sometimes I give the question, put the X on the right, sometimes on the left. The area could be on the right also, or it could be also in the left. And that's why you need to do this sketch first. You know, this sketch is like you plan how are you going to work in the question. And you also expect what will happen, because if X is 80, which is smaller than 100, then the Z will be expected to be negative. You cannot find it in the positive part. So planning the question ahead of time by this graph help you, go smooth in the steps after that. Clear now? Clear? Any questions about that? So that's an example of how things go. Sometimes, of course, the question is just a small piece. This is a real application. This is a full application. But we can have a small piece, like only how to use the table. Some of the questions, if you look at the questions in the final exams, like, not this one. Okay. This question, for example, just delete that. See, that question here is very simple. It's just giving you a graph. It's giving you the area. He just wants the Z. So it's just like a small piece. This question, one of the questions of the final exam, is giving you the area. It's telling you that this area here, it's actually this part, is 0.4850. This is like a theoretical question to test if you really know how to use the table or not. It's not like a real life variable, continuous variable or anything. So it's just a small piece giving you the area on the Z. So all what you have to do is to go to the table and search for the area given and then locate Z. But we need to do something, right? Because the table doesn't understand the area from 0 to Z. The table only understands the area from minus infinity to Z, right? So we need to calculate this area first before going to the table. How much is this area? 0.5. Exactly. See, remember, this whole part is 0.5. Remember, there's a symmetry. 0.5 here, 0.5 here. Okay? Sorry, maybe this could be just this part here, this part from this half to the left side is going to be, the area is going to be total 0.5. So if the total is 0.5 and you know this piece is 0.48, so that means this for sure is actually 0.5 minus 0.485, which is equal to 0.015. Okay, so that's what you have to do before going to the table. If you don't do that, you take the area given in the question directly, you will make a mistake, because the table is not ready for this. The table is only ready for the area to the left of Z, which is from minus infinity to Z. You understand this? This is where the play happening in chapter 6. To know where is the area, where is the Z, what do I do to fix it? Do I need to add something? Do I need to subtract something? And just simply come from knowing the characteristics of the curve. The curve is symmetric. The curve has half here. So the total area is 1. Knowing these things will help you, figure out what to do. Clear now? Once I got the area 0.015, it's very easy. All what I have to do is just to go to the table and search for area 0.015. Okay, again comes a problem here. Some people by mistake think, okay, 0.015, so you start looking at 0.015 here on the Z. That's wrong. 0.0 here. No, this is Z. We don't have Z. We have area. Remember the question sometimes start by the area and ask for Z, or start by the Z and ask for area. So be careful. What is given in this question is actually an area. That's what's given. And Z is required. So the area is in the middle of the table. You cannot find it here. There are very large numbers here. So you go to the previous page. Maybe you'll find it here. Where is 0.015? It's 0.00019. No, that's it. 0.015. Yeah, this is a Z. Yeah, so if you want to know Z, just go to the left, look, you'll find Z. So that Z is actually minus 2.1. Okay, Z equal minus 2.1. Actually, that's the main part of Z, but there is a higher precision part. This higher precision, you will know it if you look up. You find 0.07, right? So there is extra 7 digit here. So that actually the table, the Z is written two places. Part of it on the left here, and that's the part I told you about earlier. But there's a higher precision part of Z is also here. So this first part on the left column and that small digit, or the last digit on this at the end, it's actually the second decimal place, which is actually on the top row. So that's the two parts of Z. Okay? So starting from area, I got Z, so the answer is Z equal to minus 2.17. So that's the answer to the question. So that if you go back to the question, you need to figure out the area first and then use the table properly. You need to figure out the area first, which of course is 0.5 minus this value, and then go to the table and use it properly. And it's just half mark because it's just expecting you to do that, you know, as a simple step. Maybe this should be 1 mark. I don't know. Maybe it should be 1 mark. There's still 2 steps, right? You have to figure out that the total is half, and you do half minus, and that should be, and then finding the table. Yeah, maybe this should be a 1 mark question. But the next question, look at the next question. The next question is 2 marks, because that's a real full application here. Now. You have a full application, not just a small step. You have a variable, a continuous variable, which is the score in this case. You have the mean, and you have the sigma, and then you want the probability that a selected adult have an IQ between this and this. So let's have a look at this question now. How do we solve this example? As you read, write, or draw, in other words, step by step, so that you picture the question in your mind. Okay, I have normal distribution variable, the variable x, normally distributed, and this is the score, the IQ score. That's my variable. It has a mean, mu, in the middle, is 100. It has a standard deviation, sigma, equal to 20. So as I'm reading, I'm writing what I reach, and I just wait. Now find the probability a randomly selected adult has an IQ between 80 and 120. Where is 80? 80 is higher than the mean or lower than the mean? It's lower, so it's going to be here. That's 80, that's x1 equal to 80. And then the 120 would be higher than the mean, it's here. So that's, I call this x2, which is also 120. So he wants what? He wants to be a between, the probability that the selected person has a score between. So what does it mean? Yes, exactly. I need to get Z1 from here. I need to get Z2 from here, and then I also need to get area 1 from the table and area 2 from the table. Right? And then I need what? Remember, I need the area in between them. The probability is lying between means you need the area between. What is the area between them? It's actually area 2 minus area 1. So in this case, why is that? Because remember, the table gives you area 1, which is to the left of x1, which is coming from minus infinity to here. And the table also gives you area 2, which is from minus infinity to here, to x2. So if you have from minus infinity to x1 and minus infinity to x2, if you want to get the area between x1 and x2, just subtract the areas. Does it make sense? Does it make sense? Imagine I'm standing here, the area from the door to here, to this end of the board, and then I have the area from this door to the other end of the board. And you want to know the size of the board, just subtract them. So I will get area 2 minus area 1 at the end, the big area minus the small area. So let's just, now you design the question, you graph it, picture it clearly in your mind on paper. Now the rest should be easy after that. Now you understand the question. Everything else should be easier. Because you just follow the steps. You know, get Z1 equal to x1 minus mu over sigma. And x1 you have it 80 minus 100 over 20. So that would be minus 1. Area 1 from the table, if you just go to the table. Okay. Z is minus 1. But look in front of minus 1, what do we have? Minus 1 is going to be here. That's it. Minus 1 here, the area is 0.1587. 0.1587. So you're just going to say is 0.158. Okay, and then you're going to do the same thing for the other z. So you're going to say here, okay, z2 now is going to be equal to x2 minus mu over sigma, which is 120, minus 100 over 20, which is equal to 1 this time. So we have z equal to 1. You come to the table and go, the table is 2 pages, by the way. You have one for the negative z, one for the positive z. So we're just going to go to the second page, which has positive z. So z here is 1, and I can see that one, right? That one here. Z equal to 1, and the answer is this one, right? So that means area 2 equal to 0.8413. So I got the second area, and now the answer is going to be the difference between them. The answer will be area 2, the big area minus small area. The answer must be positive. Remember, it's probability, it must be positive. So the answer, from here, we can say that the answer is area 2 minus area 1, which is 0.8413 minus 0.1587, get that, whatever it is. Clear now? Okay, so that's the steps involved in solving a normal distribution question. Usually the question comes like that. I give you x1 or x2 or both of them, and I want it between them, or I want more than that, or less than that, and that's how you get the probability, is to get the area. However, the question can be the opposite. The opposite means what? Maybe I will start by the area. I will give you the area, and I ask for x, x1 or x2, or both. That could also happen. That could also happen. I give you the area. When I give you the area, it means, remember, the area represents a probability, or actually also a percentage, because remember, starting from chapter 4, we told you the percentage sometimes used also as a replacement for the probability. So I can give you as a percentage, or I can give you as a probability, right? So this question, for example, is actually start by giving you the area, not the x. He asked for x. So this question is reversed. Okay, sometimes I give you x, ask for the area. Sometimes I give you area, ask for the x. Regardless of this direction or this direction, you have to pass by z in the middle. So let's graph the question step by step. Let's graph that. The average price of a new one-family home is this. So we have now a price, our variable. Okay, we have a price, our variable. So we're going to make a small graph of how it looks like. This is the price, x, right? And then the mu in the middle is actually 250.300. Okay, and a standard deviation sigma is going to be 14500, right? Find the minimum and maximum prices of the houses that the contractor would build to satisfy the middle 60% of the market. 60% of the market, which means 60% of the prices. Where is the middle 60% of the prices? First of all, that's an area. That's an area. Giving you percentage or probability, that's actually an area. So the middle 60 would be here. This is 60% in the middle. That's the middle 60%. The mu is exactly in the center, which means you have 30 to the right of the mu and 30% to the left of the mu. The remaining, how many percentage remaining from the 60%? 40%. Yeah, 40. These 40 are in the tails. That's what we call the tails. This is a tail, this is a tail. So the remaining 40 are distributed equally on the tails, right? So the equally, why? Because of the symmetry again. The symmetry, remember this shape is symmetric. So if I tell you middle is here, I mean the tails must be equal. So I have 20% here and 20% here. So why am I bothering analyzing the whole graph like that? Why? Do I have to do that? Yes. Yes, because the middle area is not going to be useful to me. The table doesn't take the middle area. The table takes what? The left area, right? So if you want to know that value, and that's actually what he's asking about, you must prepare the area to the left of it. So that's why you must do this analysis to come up with area equal to 0.2, and here you can start going to the table. If you don't do this graph with full analysis like this, you don't have the area on the left, and you cannot start the question. You can't start the solution. You understand? So that's why the variation of this question will like give you sometimes top 60%, bottom 60%, middle 60. Top means on the right, the 60% will be on the right. Bottom means it will be on the left. Middle will be like that, in the middle. Okay? All right? And you have, yes, the graph is always symmetric. Yes, it's always symmetric. And now you got area, you can get Z, and from Z you get the X. Okay, so now you have area 0.2. After this analysis, you can just go to the table with area 0.2. So that's, where is 0.2 here? Remember, we're looking at the area here somewhere, which is going to be this one. 0.2, 0.2, 0.2. Where is it? Yeah, between these two values. Which one is closer to 0.2? I think this one. This one is, yeah, closer to 0.2. So that's almost the area.
So we take the closest?
So, yeah, we take the closest value. Yes, we can't find exactly the same value, you know, most of the times. So you have to take the closest value. You just go here left to get the main part of Z and look up. Okay, so actually Z is going to be minus 0.8. You know that this number is 0.80. This is 0.81, 0.82. 3, 4. So that means it must be 4 here. Because the first number is reserved for 0 digit on the right, and then the next for 1, 2, 3, 4, and so on. Okay, so that means the Z is equal to minus 0.84. Okay, you should do the same thing here. If you come to the second part, you should know that the area here too is actually 0.8, because you add the 60%, which is 0.6. So you do the same thing, okay? You go to the table again. So I got this part for Z1, Z2 from the table. You go to the table again, and you will find Z2 equal to 0.84. Okay? I know that. I know that because of a reason, which is a symmetry. There's a symmetry, remember? This is exactly in the middle. So if it's exactly in the middle, I know that Z will be the 0 here for the standard score Z. So if the value here is minus 0.84, for sure this is 0.84 because there's symmetry from the beginning. Otherwise, something is wrong. So you can go double check that. Just go to the table with this area. You will find Z equal to 0.84. So I got Z1, Z2. The next step, of course, is to get X1 and X2. Again, remember the formula Z equal to X minus mu over sigma. Mathematically, if you multiply Z times sigma and add mu, that would give you X. So if you're good in mathematics, you don't need to memorize this one. But if you're not good, memorize it. Because we will not give you this formula in the exam. We will give you only the first one. The second one comes from it. With a simple math in solving equations. But if you're not good in that part yet, just then you have to memorize this one, because that's just another way to write the same equation. And now you need X, so you just multiply Z sigma for the first one minus 0.84. And then sigma is actually equal to 20. And then add mu, which is 100. So this will give you the first. Oh, I made a mistake. The mu is not that. No. The sigma is, wait. This is 14500. That's the sigma. Yeah, because it's a different question. Yeah, we're talking about this sigma and this mu. Yeah, I think I made a mistake. This is not the question. The question we're having is this, right? Yeah, this is the question we're having. So I made a mistake. So this is the question we're having. This is mu, this is sigma. So you add mu after that, which will be 250, 300. Anyway, you calculate that, whatever it is, and the same thing for the other x. So this will be like x1, and x2 will be the same formula, but you have z is positive, 0.84 times 14,500 plus also, see the same formula doesn't change, only z is changing. Everything else is the same. Some people get confused here. The formula doesn't change. Okay? So just calculate both of them, that will be x1 and x2. Yeah, by the way, if you scroll down, you find the answers. So this is a final exam which has already been solved. So if you just scroll down, the answer will be at the end of the test. You scroll down here. I just have to delete that in order to see the answer. And then The answer will be like that, something like that. Is that what you got? Yeah. All right? So these are some of the examples of how chapter 6 talks about, the normal distribution. Okay, any questions about that? This is not everything, there is one more thing left. But this is most of the questions, not all the questions. One thing is left related to chapter 5. But the normal distribution, as a normal distribution to solve the continuous distribution probability problem, finished. That's it. What is remaining now is how we can help some of the questions that we could not answer in chapter 5, which was binomial. That's the remaining part. But before I start that, do you have any question here? Okay, I said that quickly because I just want to have a quick review. You just go back to the other videos and watch them slowly, step by step. Okay, now the second part where this chapter is used actually, or the last part is the last question also coming in final exams. It is a binomial question. It is not a continuous variable. There is no continuous variable here. There is no mu1 sigma. It's just a binomial question. Look carefully. I have a percentage, 49% of the people have O blood type. So that means the others don't have O. And whenever you have this kind of percentage like that, it's dividing the population into two halves. People who have it, people who don't have it. So it's like success and fail. Success is having blood type O. Fail is not having blood type O. So when you select a person, what is the chance he has blood type O? It is 4.49, and that's actually P. And the probability he doesn't have this type is actually Q, which is 0.51. And you keep selecting again and again and again and again. That's how many times selections you have N. In our case, N is 256, which is a very large number. And whenever you have a large number like this in a binomial, you cannot solve it. Why you cannot solve it? Because in the calculator, if you try, the formula, what's the formula? It has NCX, P power X, Q power N minus X. Well, the NCX, you cannot get it. Calculator cannot calculate NCX for N equal to 100 and X equal to 100 something like that. It doesn't work. It gives you a math error. It's just too hard for the calculator. So if you cannot solve it with the calculator, it's not in the formula. It means, it's not in the binomial table, of course. So we need another solution. We need a new solution. The new solutions comes from chapter 6. How come? Because remember, this is a binomial distribution. The binomial distribution is discrete. So imagine you have a discrete variable, and X, of course, here is the number of successes. This is the number of the people who have, O type blood or blood type. So this is considered to be the number of success at the end of 256. So we have this X is anything from 0 to 256, which is N, right? And this is, if this is the probability distribution P of X, remember it's going to be a vertical line, it's like that. Remember how do we graph the binomial or the discrete in general? It looks like that. You have different values. For every X, you have a probability, and you graph them like that. It's discrete because X can be 0 or 1 or 2 or 3 or 4 or 5, right? When you selected 256, either 0 of them has blood type O, or 1 of them, or 2 or 3 or 4. That's a discrete variable. But because this discrete variable has so many possibilities, we can say it's approximately continuous. It's not continuous, but it's like being close to continuous. What type of continuous? Normal distribution. Why? Because actually the binomial shape looks like the normal shape. The only difference is that the normal is continuous and the binomial is discrete, but the shape is the same. So we can approximate this binomial problem to become almost like a normal distribution. So the variable X, which is the number of successes or the number of all blood types here, which was discrete, we can assume it's almost continuous. So if you want the probability, that would be 166. 166 is here. It's actually going to be one value in the discrete, but actually it's going to be an area in the continuous. This area is centered around 136 using the boundaries. So the width is just 1, which means it's actually starting from 135.5. to 136.5. You're just adding half, subtracting half to get the boundary of the value, and this way you're forming an area under the normal curve. This will give you the probability. So if you calculate the probability here exactly, suppose you have a supercomputer to calculate the area here, and you also calculate it from this area under the normal curve, they'll be very close. So that's it. But by the way, in our example, it doesn't say 134. I'm just telling you if it asks for 134. It's actually one at least which means 134 and above. So we need this bar, and we need this bar, we need this bar, we need this, all of them. So we're actually starting all the way from 135.5 to the end. And that's why a question like this, if you write it in discrete terms, probability that x greater than or equal to 134, that's a binomial. But in fact, if you convert this to normal distribution, it's actually x greater than 135.5. And that's why you see starting, sorry, I made a mistake. This is actually, wait, this is not 6. Oh, let's just make this 6. I made a mistake. 136, assuming it's 136, just for simplicity. Okay, I just thought this 136. Okay, 136. So 136, it means instead of having 136 here, bigger than or equal to 136, it actually becomes more than 135.5. We start using the boundaries here. Where did this idea come from? Why do we add or half or subtract half? Because every value in the discrete becomes an area in the normal distribution. And the area, for the area, we use the boundaries. That's why. Okay, so from the graph, it looks like if you understand what you're doing, then you're actually starting from 135.5. Of course, if I say at most, it would be different. At most means maximum 136. So at most, which means you're using this bar and the ones below. So that means you're doing all the way from minus infinity to where? To here this time, because you're using the bar and using the bars before. So in this case, it will be starting from 136. So that's like, this is x1 here. The second example, if I make it at most, it would be 136.5. So that's why sometimes you add 0.5. You know, if you have at least, you subtract 0.5. If you have at most, you add 0.5. So people can get confused here, right? But if you do a small graph like that, you will not be confused. Right? But because still people get confused, we have a table that will help you in the formula sheet. If you look at the formula sheet here, that one, that's the formula sheet. Look at the formula sheet here. I tell you, if you have at least, this is how you write it in the binomial, this is how you write it in the normal distribution. If you have at most, this is how you write it in the binomial, and that's how you write it in the normal. So you know here you subtract half, and here you add half. So that's the table of all the possible examples, right? You don't need this table if you do this quick graph, of course. But anyway, you know where the table comes from. Anyway, let's go back to the question. So now what am I going to do? Let's go back to this question. Again, I said I erased everything. So I said it's a discrete distribution, right? Right? I want one, let's just solve this. This is 134 and above. So in fact, I need the bar around the 134 and above, the bars that comes after that. So I'm really starting from 133.5. So that's like my x1. I need to get z1 after that, which is x1 minus mu over sigma. And then the area, of course, on the right. The area on the left will be what the table gives me. So the area one will come from the table, and the answer at the end will be 1 minus area.
But how do you find the mean?
But the question here, how do we find the mean? Yes, how do you find the mean? How do I find the mean? The mean is the mean of this shape, this distribution, which is actually also coming from this shape, because the mean is the same for normal and for binomial. Remember, what is the binomial mean? Who remember the binomial mean, mu? NP. NP. So the binomial mean is going to be the normal distribution mean. It's actually going to be the same. And the sigma is actually, remember, n here is what? N is 256. And p, we said that here, p is actually 0.49. So you just multiply them. Sigma is the square root of n, p, q. So we use this mu and sigma here to calculate the z, because it's actually, for the normal distribution, we're borrowing the same characteristics from the binomial. we're using it again in the normal distribution, so it's the same. Okay? So I got the nu and the sigma to help me calculate the z. From the z, I get the area, and then, as usual, I subtract 1 because I use a complementary indices. So it's really a little long here, and you need to prepare the sketch to know where you're doing, how you're going to do the progress. There are plenty of areas of making mistakes. Some people, for example, because they got used to solve this question with boundaries, any normal distribution you use boundaries, which is not true. We only use the boundaries when we move from binomial to normal distribution. We don't use the boundaries otherwise. So some people mix up that thing. Okay. And also there are area for, if you use a boundary, should we add or subtract? And that's an area also where sometimes people get confused. And as I told you, if you make a graph, good graph, it will help you. Or you can also look at the table given in the formula sheet in the final exam. Okay, but these are the two types of questions. We have a question that's originally normal distribution, continuous variable. And we have another question that's originally a binomial questions, which has P and Q. The percentage is P given in the question usually, right? And we have n times selections, and you convert from the binomial to the normal. Okay? So maybe I was quick, fast, but I just wanted to summarize the whole chapter quickly. Okay, the rest is variations. The examples you see in my website are different variations. If you look at the slides, different variations. If you look at the homework or the active learning or the videos on YouTube, all these are different variations of the questions, which really require good practice from your side. You still need to practice that. Because, again, the area could be right, could be left, could be at least, could be at most, and still get confused here. And you need to have enough training so that when you see the word in the exam, you don't get confused. You don't puzzle, what does at least do? I forgot what do I do when I see at least. I forgot what do I do. No, you need to see enough questions so that it becomes easy for you what to do exactly when you see at least, what you see when you see at most, more than what it means, less than what it means, and so on. All right, guys? Any question about that? Okay.